Sometimes when we're solving equations, we need to remember and use some of our identities to help us get there. And that's the case when we come across something that we can't factor. So looking at this one, I remember there's an identity that involves cosine squared of x that we become used to using a lot. So cosine squared of x also equals 1 minus sine squared of x. Love that identity. From there, let's just do some work for a while. 2 minus 2. Looks like I have emerging quadratic to move towards. So I'm just rearranging the terms in quadratic form. I think I did all right there. Just double checking, a lot of work. Let's multiply everything through by a -1. So I have a leading coefficient as positive. Zero times a negative, just zero. Love zero. From there, looks like we have something that if I maybe substitute and let u equal sine of x, then I have 2u squared minus 3u minus 2 equals 0. I can factor that now. That's a 2u and a u minus a 2 there and a plus 1 there. Did that factor correctly? I believe it does. Then from there I can resubstitute my u substitution in. So this is the same thing as 2 times u, which was a sine x, plus 1, times a sine x minus 2 equals 0. From there, I know that's true in either one of those cases. So let's explore 2 sine x plus 1 equals 0. And sine of x equals -1/2. Looks like I have a solution in the second and third quadrants. Our third and fourth quadrants. Try to figure out what my signs are negatives. Signs are negatives in the third and fourth quadrants. So that's true if that's pi sixth. So one place in the third quadrant, that's pi plus a pi sixth, is where that to be true at. And that equals a 7/6 pi. And the other one's in the fourth quadrant, so let's go to 2 pi, take away a pi sixth. And that equals 11/6 pi. So where do I have a sine? The sine of 7/6 pi is a -1/2. The sine of 11/6 pi is a -1/2. So there's two solutions that I found. And then if I added any multiple of 2 pi to either one of those, that would take it beyond my interval. So those are my only two solutions within the interval from 0 to 2 pi. Now we need to explore the other part of it. This was the first part. Now let's explore the other part, which is a sine of x minus 2 equals 0. Sine of x equals 2. Notice that my value there is beyond -1 or 1. So there's no sign that produces a value greater than 1 or -1. So there's no solutions in this particular one. So all my solutions for this original equation between 0 and 2 pi were found right there. Another use of using an identity to help solve a problem where you might not be able to factor right away is this one's going to use cosine of 2x. You remember an identity that's associated with that one? It's one of our double angle identities. So cosine of 2x was the same thing as 1 minus 2 sine squared of x. And in this particular case, plus 3 sine of x minus 2 equals 0. Let's see if that helps us move us down the road that we need to move towards. I can add 1 to there, so I have a negative 2 sine squared x plus 3 sine x. 1 plus a negative 2 gives me a negative 1 equals 0. Let's multiply through now to get a leading coefficient of a positive. Let's multiply through by a negative. So it's 2 sine squared minus 3 sine x plus 1 equals 0. We're going to see if that factors. Again, if it's helpful, we can do what we call a u substitution, where we're going to pretend that u equals the sine of x. If that's the case, and this problem's the same problem as 2u squared minus 3u plus 1 equals 0. Let's factor that one down. 2u and a u, that one becomes a a 1, so 2 times okay, got it, folks. Just wasn't looking right. Negative 1 and negative 1. Almost forget how to factor. And so u minus 1, 2u minus 1, that makes middle term is a negative 3u. All right, just sat there and stared at it forever. Finally, it kind of clicked. All right, then we can substitute my value for u back in. So I would have then 2 times the sine of x minus 1, and the sine of x minus 1 equals 0. That's true if either factor is equal to 0. So let's look at both of those. 2 sine of x minus 1 equals 0. Sine of x equals 1/2. We know that occurs at the value of pi sixth. So sine of pi sixth is 1/2. That's one value of x. We know that sine's also positive in the second quadrant. So to find that one, we would do 2 pi minus pi sixth, or sorry, pi minus pi sixth, and that gives me 5/6 pi. So those are the two values and the first and second quadrants that fit within my interval. Again, any 2 pi above that pushes out beyond the interval. So that's all the solutions for the first one. The second one then, we want to look at the sine of x minus 1 equals 0. Sine of x equals 1. So where is the sine of x equals 1? That occurs at pi halves. So x equals pi halves. There's nowhere else where the sine of x is a positive 1 within the interval from 0 to 2 pi. And so there's my solution, and then any solution of adding 2 pi past that would also be a solution. But again, we're restricting our solutions between 0 and 2 pi. So my three solutions then are pi halves, pi sixth, and 5 pi sixth. Again, another equation that we can solve, but we might have to solve by using one of the various identities that we've been playing with over time.